Are y'all doing? Well, Monday night, and it is another exciting edition of the Physicist and Philosopher.
Mhm.
Hello, Dr. Albers. How are you?
I'm very well, thank you, Wayne.
Good.
And how are you?
Wonderful. There's a great movie that was out called Wall Street. And I don't know if you ever saw it, but it was one of my favorite ones. And the famous line is there when they asked Bud Fox, who was Charlie Sheen, well, how are you doing? And he says, well, they was saying, you look pretty innocent. And the guy says, I was never that guilty. I think I just screwed that up completely. So anyway, hello, everyone. Boy, the crowd is growing quick in here. Thank you to all the moderators. Hello, Gary Baxter. How are you doing? Big D, Mad Hatter, Skies Above. You know what, Claudia? The classroom is definitely filling up quickly.
Wonderful.
How was your weekend?
It was very nice. It was very peaceful, actually. It was quiet, and that's what I like. I like peace and quiet, actually.
Excellent, excellent. You got snow, I hear.
Yes, we had snow this morning when we woke up, and I kept thinking, why is there no spring? Why? It's supposed to be spring. Why are the trees still looking so dead? Why are there no leaves?
So, folks, you really have to take this into perspective. Remember, Dr. Albers lived in South Africa. So this
Yes.
is literally upside down and backwards. So, wow.
Yeah.
What is the time difference? What is that like?
It's 6 hours at the moment. It's six
Oh, six
hours.
hours. Okay.
Yeah.
All right.
So it's 6 hours later there than here.
I have a question that someone asked, and
Hmm.
when you and I had talked right before we came on, one of the questions was this: this is how it was posed. We know that the universe is moving. We
Hmm.
know our galaxy is moving. These are established fields or speeds according to astrophysicists. They can measure not only light, but they can measure as well, I think, chemical um, reactions to light, et cetera, et cetera. You would know that
Hmm.
better than I. The
Okay.
question is this: we have all these objects moving, right? Why is it that the stars never change?
Well, the thing is, they are moving at huge speeds, but because the distances are so great, they would take billions of years to move according to how far they are from us.
Mm-hmm.
So you see, if we're at the center of a circle and we're looking at something at the edge of the circle moving around us in a circle, if the circle is a short circle, it doesn't take too long for that an object on the edge to go all the way around the circle, right?
Right.
But if you make the circle larger, then it will take longer for an object at the edge to go all the way around. And the further out you go, the longer it takes.
So they say that we only have basically about a 3% view of of the Milky Way, of our galaxy.
Mm-hmm.
Okay, I get that. And I get what you just said. So if we're closer to the center, oh, excuse me, always that the relation to what we would be seeing would be almost like a top,
Yeah.
right?
Mm-hmm.
So the
So,
visual view would be the same.
yeah, you see, what happens is we are seeing the distances are thousands of light years. And when you're looking at an object that's thousands of light years away, even though it may be moving very fast, even at one third the speed of light, because the distance is so large and so far from the center of the galaxy, it takes millions of years for us to see it move just a tiny little bit.
And I just snapped to that because what you're saying, and I'll just translated into Wayneism, is that that what we're seeing is actually the distant past. We're not
That's true.
seeing where those objects are in present day.
Exactly.
Ah, that's a
That
mind
as
coitus.
well, because it takes light millions of years to travel
It,
that distance. So we are seeing the light that left millions of years ago.
this is a good argument. Thank you, Dr. Albers, because this now establishes for me that why I can see Polaris, why I can see Beta Reticula, and that the deviation in what we have been able to track is you just said, we're only tracking 7,000 years maybe of data, maybe less than that, maybe 5,000.
Yeah, I mean, our view of the universe is always looking into the past, and the further away we are looking, then the further in the past we are looking. You know, but
That's
the
remarkable.
thing is, one of the things I've discovered is that a lot of the galaxies are actually closer than established science will tell you. Because again, we'll have to go back to the fact that they use redshift to determine how far they are. And redshift, as I mentioned before in our other talks, is intrinsic. It doesn't tell you how far these objects are. So they will say things like, these objects are so extremely bright. That's because they're viewing them wrong. They're not that bright. It's just that they think they are so far away, when in fact they're supposed to use the brightness to determine how far they really are. So if they seem to be so extremely bright, it's because they're a lot closer to our galaxy than the use of redshift would tell you.
Interesting.
Mm.
And that's part of the book, that how I started seeing
Yeah.
that as well. It's still a
Alton
little
Arp's
ahead,
book.
I feel like I'm kind of climbing up there going, okay.
Yeah, I mean, the way Halton Arp writes is actually quite complex. He uses quite complex language,
Yeah.
but I think the pictures speak for themselves. You have to go through it carefully, but just the first chapter just tells you the whole story.
It does. And I've read that several
Yeah,
times. And, and this is a case when you can actually say you bought the book to look at the pictures.
exactly.
Because it's complex. It's advanced math. It's obviously advanced theoretical astrophysics. And it's,
Yeah, he uses terms because he basically wants to convince his colleagues
yeah,
as well as tell the general public about it.
indeed. And I think I actually, yeah, it's still right over here on my other desk. So, yeah.
So he believes that his colleagues will still come around. I don't believe that. Most of them do not want to know because they're more interested in their careers than knowing the truth. Plus, they know their career will end if they even start talking about how things really are. Their papers won't get published. They lose their careers like I did.
You
I
know
mean,
what? All I've got to say is that is tyranny, that's repression, and it shows to me, excuse me, on a philosophical level that there's something inherently wrong with our species when you have those of our races, Claudia, that purposely try to imprison the mind. I mean, that is repressive. And you can never say we are a progressive society when that type of bigotry, that type of, and I'm just going to say that's racism. That is out and out. And I'll call any university out on this. You are a racist. You are a
yeah,
racist that is the same difference than what we could say has been in every other repressive society and regime. All
yeah.
right. I'll get off my
Thanks, Wayne. Now, if
the
I tell
following
you
is a
what they
commentary.
actually did to me, what my head of school did to me was he tried to get rid of me by doing something that is never done to any lecturer. a lecturer is usually given free rein to do what they want in their course, to use the textbook they want. But from the time that I started writing, I realized what happened, that someone went behind my back and somehow set me up, because my head of school did something to me that had never been done to anybody else at WITS. They forced me to change the textbook to a textbook that I loathed. I couldn't stand that textbook. And my course had, all my students loved the course, had good grades, they loved me, but they forced me to do something that I would never have done. And then he said to me, you have to teach this course and someone else is going to be coordinator.
Oh,
yes, yeah. This is what he did to me.
That's a censor.
Because he wanted to force me to leave.
Oh, you know what? What a butthole.
I know.
That's all I gotta say.
It's unbelievable what was done.
And I'll just say this from an intelligent point of view. That individual needs to go to the doctor, because obviously his cranium has been stuck in his anus, that where the fecal matter now has been replaced the gray matter.
Yeah. And now I realize what happened, that all these trolls were working. I mean, I was working with somebody that I trusted and believed to be my friend, and turned out to be a troll. He was obviously setting me up.
You know, all I got to say to the people that give that type of nonsense so much energy,
mm-hmm.
because it takes a lot of energy to do that kind of stuff. And for what? For what?
Because I was going against the establishment.
Oh,
and
I
they
know.
close ranks. And I tried to speak to my colleagues and say, look what's happening. And no one wanted to help me.
Yeah. Yeah.
You know, so.
Well, I'll tell you, it's repression. And any way you slice it and dice it. And, you know, you just get sick of it. At some point in time, I just really do believe our species is going to get together and say, enough of this.
Mm-hmm.
Well, you know, Dr. Albers, that's why our show is so successful, because people like you. Mm-hmm. They want to hear, they want to learn. And I appreciate that. And they do too. And yeah. Hi, Wendy.
Yeah, I mean, I love teaching. I've always loved my students, try to do my best for them.
Yeah.
So, because I enjoy teaching, I enjoy seeing that brightness in people's eyes as they understand something new.
Well, I'll tell you, we're going to learn. I think we're going to learn a different way to attack that. And that is by being open and forthright and welcome everyone's opinion. But we're going to show that free thought does require to be a free thinker.
Yes, that's right.
So I have something for you that someone asked by viewer request, and I am pulling it up now. Allow me to pull this up. So here we go. So, Claudia, I have gone back into my archives and I pulled up some of the old SETI Stereo B footage. And I thought this is going to be fun. So I found this in, can you see that?
Yes.
All right. So.
Oh, yes.
Oh, yes.
Lovely.
It is lovely to see you again, my friend.
All right, my goodness. Look at how huge that object is.
Look at that.
Oh, my goodness.
So I have been able to, and I've got another one for you that you can't get this footage anymore because the camera, that camera doesn't work. They turned it off, whatever.
Yeah, it's stereo B, isn't it?
Yes.
Yeah.
So
they don't want us to see things like this anymore.
No. I started watching this and I started doing some analysis on this. So the sun's over here,
yes.
you know, This is what's so freaking weird because that's Earth.
Yeah, well, they label things whatever. It's
Yeah.
usually not what they label it as.
So what's
I don't
going on
think
here?
I don't think that's Earth.
Okay. I'd agree because it's hot.
Yeah, it's very bright. It's obviously I mean, it's possible that it's Earth, but it's Earth reacting to something else. And I know now that we have stellar cores in
Yes.
orbit around the Earth, so it could be that. But it's definitely not just our normal Earth. But a lot of things are happening with our planet, and because of these stellar cores. But this you can see that interaction. It's just amazing. And you see what we have there in the background seems to me to actually be two objects, because these stellar cores often cluster. And so it looks like two, one in front of the other. Look at that.
Yeah, this is what got me. And there's a third one right over here.
Yes.
And yeah, this one gets really weird.
It is very, very
It
weird.
just gets weird.
Don't forget, the sun is very small in these images. It would be about the same size as the Earth seems to be.
Look what's happening here. I stopped the frame here because this one blew me away.
Oh my goodness. Look at
The
that.
sun's over here, folks. It's over here.
And it's
Something
tiny.
happened here. Look at that.
The sun would look tiny to stereo B.
Yeah.
The same size that it would look like on the core 2 images. That little circle that indicates the size of the sun.
Yeah.
That's the size of the sun in these images from stereo B. So it will be tiny. So that object over there, that huge circle, that's a huge, huge object.
And I know they call this maybe the Birkeland current or whatever, but this is off the scale. I have never, ever seen something.
Yeah. Do you know what it probably is? It's not just the Earth. It's something else behind the Earth or something. I don't think that's just the Earth.
Something else is going on here. I think this is why why they took this thing down.
Yeah.
Someone tried to say, well, no, what you're actually seeing here is the inner part of the camera. And I said, no, I don't think you understand. I actually have the construction drawings of this telescope. And these cameras, it's not what people think. So this is reacting to something here.
Yeah, definitely. Now, there's no way. First of all, are these the SRAM images?
Yes.
Because we see these things in SRAM images, which only detect particles.
That's exactly right.
They cannot be any lens flares in them at all. So this is not a lens artifact at all. That's impossible.
Look at this object coming in here.
Yeah.
It come there? Do you see that? Look at that.
The sun is reacting to it. The Earth or whatever is with the Earth is reacting to it.
Let's see if we can actually stop right there.
We can see these huge interactions here. And look at that circle moving in. It's almost like a bow shock kind of thing.
Exactly. This whole thing just reeks of a bow shock wave. That's what I'm thinking of. And whatever's going on here. Now, I have something else for you. So allow me to get back here. And I hope everyone's enjoying this because I have more. So let me pull this up. So upon doing some searching, I found something, Claudia, that this is going to be, I can't wait to get your reaction on this. So let me pull this one up. Yes, this is it. Okay, I'm going to cue it up from the beginning because this is the most remarkable footage, and I actually have it. Wait a minute, stop there. Okay. All right. So I have this, and here it is. So can you see that?
Oh, yes.
All right. So this is the Milky Way center. Just to let everyone know
Well,
this.
that's what they
They
say.
say. Now, here is our object again. Whatever
Uh-huh.
this is, the sun is over here to the left. Now
Yeah.
watch this. What the look at our little friend.
Oh my, yes. Look at that. Isn't that
So
beautiful?
let's just stop here. So folks,
Oh my goodness. Look at the big
I
circles
know it.
on it.
So folks, just to let you who don't know what this is, they put this thing. This thing is like it's a piece of plastic, literally, that is they put it there for some reason. Why?
Yeah.
I don't know. What, Claudia, what is your thoughts?
I actually think they digitally added this in because I looked at a lot of images where you could see light emission right through it.
Right through here. Okay, so then
Right
they're
through
blocking this.
So I think they actually digitally added that in order to confuse the eye so that we wouldn't see the object that somehow is always there. Because I think they actually took the stereo spacecraft and they were tracking whatever was there.
Now, the one thing that I agree with you, I agree. That makes sense. The thing that I don't understand about this particular picture, one thing here, the background is different, but we get light out here. This should not have any light at all. There should, look at this.
Yeah.
We're getting something out. It's one of these. So let's just play this. Claudia, this thing is already, yeah, I'll just.
Yeah, you can see there is light emission on the edges. Yes.
Yeah, this doesn't make sense. It should.
No, it doesn't make sense. So I think maybe even that circular edge they've placed there.
Through, okay.
Yeah, that may have been digitally added as well. I'm not sure. But for us to get light on the edges like that, that's just not normal.
And this tells me this is not an obfuscation of the lens or any anomaly.
No. They digitally added that in order to hide the object that they they actually aim the stereo B spacecraft so that it looks at that so they can track it.
Dr. Albers, would you agree that the sun is reacting to this or something?
Definitely. There's definitely a relationship, some kind. Yes. Actually, that object is reacting to the sun and the sun is reacting to it.
This is why I love going these by frame. Look what happens here, folks.
Look at that. Yeah.
Yes. And the crazy thing is what they.
You know what happened there?
Go ahead.
The sun went dark.
It did.
I mean, I've been saying for years that the sun goes dark.
And I know people aren't going to believe it, but folks, that's what happened here. You can't.
And look at something else, Wayne. What happened to what they say is the galaxy?
Okay.
It's not there anymore. If it had been the galaxy, it wouldn't have disappeared.
Yeah.
Not the galaxy. It's actually this cloud of debris that's in the solar system. Gas and debris brought in by the stellar cores. It's filling up the inner solar system. And most of what we see in these images is that. It's that debris.
And folks, and this is these are stars back here, right?
I mean, I hope it is. It is objects. Possibly could be some of the stellar cores that are now emitting light. The sun went dark, they're still emitting light. Because to tell you the truth, I think that the inner solar system is so full of debris that I doubt that we can see many stars through it in these images.
And I can get up the next month on this one if the audience wants us to. But Claudia, here it's emerging now.
Uh-huh.
It's shot something. This is something that it's emitting in front of this. And so let's go ahead and pull up the next couple of frames. And here it's coming out. I call
that a jet ejection.
Right there. It makes sense to me. Now the sun is still reacting, and whatever this is, I don't know what planet that is. I just got to be candid. I don't know.
Yeah, but it doesn't matter because they label it whatever they want. It just fits the picture. It's usually actually a stellar core. If there was a planet there, they just cover up the planet and call the stellar core that's bright and interacting with the sun. They call it by whatever, Venus, Earth,
Yep.
Jupiter, whatever fits.
New star.
Yeah.
So here's what really gets me on here. This thing is reacting.
Yes.
The only thing I know is that I know that these are photons because we're seeing that. We wouldn't be able to
This
see.
is more than that. This is actually plasma that this object is ejecting. This has to be an object that has been here for a while, and it's regained the ability to emit plasma like a solar wind, like a CME, like another star. Look what it's doing. And sometimes you can actually see these options open up into a huge plasma loop. And
I have more. Just give me a second because we're going to look at this in I have it in the SRAM. So let me pull this up here. And this really gets freaky, folks. Let me, and I can actually pull up the previous month. So just to let everyone know, Dr. Albers, we're looking at, this is not happening in seconds. This is this is days that this object is moving through. So let me pull up this now. I think you're going to really enjoy this one, Claudia.
This is fascinating.
All right, here we go, folks. So I'll let it play through in normal time.
Oh my goodness.
Yes. Look at what this thing is doing here.
Oh my.
I don't know what this
looks like an artificial device there.
What is this? This can't be a planet.
That looks artificial to me. Definitely.
Look at this. This thing is emitting. It's emitting particles. I mean, okay, I'm going to stop it there. So
yeah, it's too
look at the size of this thing.
Symmetrical to be a natural object. That large circle looks like a natural object, but the smaller object emitting that beam, that didn't look like a natural object. That looked like a device.
Look at that. It's so quick, folks, that this thing, it reminds me of a pulsar. The sun is over here. So
yeah.
I don't know what this is, Claudia.
Well, that one looks like a natural object. Like
this one right here?
Yeah. It looks like a star to me. It looks like more powerful than even the stellar cores that we usually see in the sun's corona. Those ones are basically dead. This one doesn't look dead.
No, it's active. And look what's happening over here.
Yeah, and that one may be one of the dead ones because it's not doing much. But then there's that little object that comes along and emits that umbrella type of beam.
Yep, here it's coming in
artificial.
Here. Look at the bow shock waves here, though, Claudia.
Yeah.
1, 2, 3 that I can see emitting here. Here's a planet. This one makes sense. I can spot that. This one, don't ask me. I don't know.
Yeah. Our planet, there are lots of signs that advanced alien technology is being used on Earth.
Yeah. Look at that.
It's being used to hide these things, and it's being used to suppress us, and it's being used against human beings, to tell you the truth. And you can see in the chemtrail planes, first of all, they travel way too fast. And Scott caught them the other day. He took a picture of a chemtrail, and you look at the beginning of it, and there's no plane there at all. There's nothing there.
Get a lot of people sending me the same thing. Claudia, what's going on here? This thing, when I look, and I stopped this frame specifically because this is emitting, I don't know what you want to call that.
It's emitting jet ejections in
Excellent.
opposite directions. This shows that this is a very active object. This often happens with an object that has an extremely high electric field. So it emits just like a galaxy does. A galaxy emits in opposite directions along its minor axis. That is along the north, from the North Pole and from the South Pole at the same time. And this is what we see this object doing these symmetric, ejections.
Look at this.
It looks like a very powerful object.
And look what I'm just saying.
Yeah, look at that.
Look at
Unless it could be one of the sun simulators. I'm not sure if that's close to Earth, because there is supposed to be one that's close to the Earth where they've used some kind of advanced technology so that it's quite powerful. It could be that stereo B, if it's not very far from Earth, is picking that up.
Well, if we're catching the right point on this camera, this is our little object right here, but it's emitting something.
Very powerful.
Very powerful.
And the fact that these rays are so symmetric,
did you see that?
It's possible that it's artificial as well. That's what I'm thinking. Because it's very symmetric kind of ejection.
This is just, look at this. What? This is a lot of energy.
It is.
And here's our object coming out here.
You see, we don't know exactly how far stereo B is from these objects.
True.
Without that knowledge, we cannot know how powerful it really is, because it could be that stereo B, this was in 2007, so stereo B was not very far from Earth at the time.
No, it was not.
So, and stereo was behind Earth's orbit.
It was?
Yeah, because stereo B was slightly behind, stereo A was slightly ahead. So stereo A could not look back at Earth, but stereo behind could have been behind Earth and could have looked at it and what was there close to Earth.
Look at that.
That is amazing. This is just amazing.
I don't know what
so
happened.
Many things interacting here.
Yeah. And I'm going, it's like, telling a child, give them a complex math formula and say, what do you think? What? Look at that now.
Oh my goodness. That's definitely one of the stellar cores, because
look at
there
this.
we're seeing a natural object.
This is
Look at that. It's huge.
And you can only do these in frames, folks.
Yeah. We can clearly see the surface, how
I can pull it back.
We can see surface features on it. That was amazing catch there, Wayne.
Yeah, if I can catch him again. Look at what this thing.
Yeah.
As you were saying, this is just blows me.
This is the object that to me always looked like a plasma ball.
Yeah.
It looks like it's made out of a transparent material, glass, and at the center there's something that emits the light. So like a plasma ball with the anode at the center. And then that parachute type thing, remember we used to call it the parachute bomb.
Yes. Well, because we actually caught one coming up here.
Yes.
Coming this direction. We caught many of them coming out here and one coming in from this direction.
Uh-huh.
So I thought you would like just to see that.
It reminds me of the work we did at the beginning. We were trying to figure out what these objects are, but it definitely looks artificial.
Yes.
And so, like I said, they're using advanced technology on our planet and probably around it in order to hide what's going on and hide the fact that the sun is dying. It goes dark.
Yeah. Well, so folks, there was just part one.
That was fascinating.
We actually had a lot more stuff here because I don't know. We fortunately, when we were researching this, I guess it's been almost 3 years ago,
Mhm.
that we've saved the footage. It's up there, and I don't know. We're a lot more, I think, intuitive now and more intelligent because you have brought forth, I think, some revolutionary new approaches to look at these objects. And instead of the ignorant masses that come in and try to say, well, it's nothing more than a lens flare, folks, these are satellites. They've spent, particularly with Secchi almost was $1 billion project. I don't think that they're going to get the Walmart special for the camera lens.
No. Plus, the fact that we see them in the SRAM images, which only detect particles, cannot have any extra lens effects because they're not lenses. They detect particles. They detect.
I don't think people understand that.
They don't have lenses. It's like a screen. And when a particle hits somewhere on that screen, that produces a little spot on the image that's produced. That's all. That's all it is. There's no lens. There's just a detector that detects particles coming from a certain direction.
I agree. Something you put out that I think now we're finding more and more articles coming here. So, what's going on here, Claudia? I have a theory, but we know that the continent of Africa is splitting in two. Now, you used to live there.
Yes. Well, there is a huge fault line there. But what is happening is the Earth is opening up. It's being torn apart by the stellar cores that are influencing the Earth and causing the Earth's gravity. They're interacting gravitationally with the Earth. And like I said before, they're causing crustal displacements. You know that whenever you have a crustal displacement, you actually have to disconnect the outer crust of the Earth from the core. And that takes a huge force for that to happen. So
that's enormous.
You can expect the crust to start splitting apart, especially where there are weaknesses. This is what's happening.
So I have, you and I talked about this. So now this tied in perfectly. So I have been getting emails from others, and I've been looking at this as well. We know because the magnetopause is collapsing that more and more cosmic rays are penetrating the Earth's atmosphere. That these neutrinos, is that right?
Well, we have all kinds of particles coming in. Cosmic rays?
Yes.
Yeah, the problem with it, you see, it's a little bit complex. We have different factors here. First of all, the sun, like I keep saying, is dying because the stellar cores are just draining all the energy that it's producing. And the energy the sun is producing is coming from its core, but it's not thermonuclear reactions. It's the opposite. It's actually fission. Because when the core of the sun formed, we had protons coming together and producing heavy nuclei with lots of protons and neutrons in them. Most of them were unstable. So over the next billions of years, these nuclei are going to decay, that is split apart, fission, and release energy. So this is what's warming up the Earth. It's the same effect on the Earth, except the Earth is much smaller than the sun. But this is what's producing the sun's internal energy. It's actually fission.
Fission.
And so the sun, over the years, has been able to use this energy to produce light and CMEs and the solar wind. Now, these dead stars have come in and started absorbing all its energy.
Interesting.
So, as they absorb all the energy the sun is able to produce, and more than it's able to produce, of course, it starts dying. It can no longer produce light. It can no longer produce a proper solar wind. When the solar wind decreases, then two things happen. First of all, it doesn't protect the solar system like it used to, so cosmic rays from the outside more and more come in. The other thing that happens is that part of the Earth's magnetic field is actually produced by the sun interacting with the Earth's magnetic field. So all these particles in the solar wind come in and they start interacting with the Earth's permanent magnetic field and produce an external magnetic field around it. So the fact that the solar wind is not blowing as strongly as it was before decreases part of that. So it decreases the Earth's protection against everything that's coming from the outside, including whatever solar wind there still is.
Well, some of the people that were talking on the on this subject was that the fact that with the increase of radiation, it is in fact heating up the Earth's core, which would then, of course, lead into the next catastrophe of what they call sudden tectonic plate shifting. I wonder if this is how that would be happening.
Okay, so I think actually the connection is more incidental than a direct relationship.
Okay.
Because we are seeing more cosmic rays coming in because the sun is dying.
Mm-hmm.
And we are seeing the temperature from inside the Earth, because don't forget the internal temperature of the Earth is the same as the sun's surface. Why is that? Because it's being produced from the same type of source, fission. But the Earth is much smaller, so the surface was able to cool down, and so the heat stayed inside. But when the sun becomes weaker, then there is this what's called the temperature inversion. And you know that because if you have a concrete wall and it gets heated all day long by the sun, you can touch the wall, and even on the inside, it's quite cool all day long. The moment the sun goes down, heat comes out of the wall.
Mm-hmm.
You can actually feel that heat. There's this temperature inversion the moment that electromagnetic radiation is not being absorbed, then it starts emitting. So the thing is, because the sun is going dark and getting weaker, the Earth is actually emitting more radiation. It's coming out towards the surface.
Okay.
So that's one of the things that's happening. The other thing that's happening is the stellar cores are interacting gravitationally with the Earth,
yeah,
and causing the Earth to break up. And when that happens, what we get is what you show there in that diagram is these fissures and the magma coming through these fissures up to the surface. And because the planet is covered in 70% of it is water, and because the crust is thinner at the bottom of the oceans on the seafloor, then most of this magma is coming up at the bottom of the ocean. So the ocean is warming up because of these huge volcanic eruptions that we don't even know about.
I read actually that this lithospheric mantle is the one that is really becoming, well, there we go. It was supposed to not do that. But anyway, that this is the one that is really, like you were saying, it's actually fracturing apparently in many different places around the world. So
yeah, it's fracturing. We are noticing it on the land masses, but it's been fracturing at the bottom of the ocean for longer.
Yes.
Because it's thinner, and it's thinner crust, and there are lots and lots of volcanoes from past cataclysmic events.
Yes, indeed.
At the bottom of the ocean. And these just start erupting, and we don't even know because they're so far below the surface of the ocean.
And I think we're seeing more and more of it.
Yes.
Yep.
And you know what happens then? The ocean warms up, and that affects the weather worldwide because the ocean has a very strong effect on what happens to the climate. It's a driver of climate.
Speaking of climate, I know I had another page up there, but this one was sent in by a subscriber. This one is a little troubling for me, Claudia, because we always think of the United States and we think about the United States leading the world in such experiments of weather modifications, geoengineering, et cetera, et cetera. What we fail to keep in our consciousness is the fact that Russia and China particularly, is apparently just, they're doing things that I just don't think most of us even can imagine.
Yeah, the thing is, the United States has been using their weather modification technology as weapons against their own people and against the people in other countries.
Mm-hmm.
So China knows that this is happening, so they're developing their own technology. And you think it's to produce rain. No, it's not. They use it as weapons.
It's weapons. By the way, I did not know this. I watched a documentary over the weekend. The Three Gorges Dam that they just built over in China, I did not know what this is doing to the mantle of the earth.
Mm.
It is 33 million hectares of water displacement now pressing in on the planet that was never there before. It's literally pressing into the Earth's crust, Claudia.
Yeah, I mean, people will do that, but if the Earth was not so unstable, and I read somewhere that someone was observing that, if you open a drain, it's supposed to spiral in a certain direction.
Yes. Yes.
And it spirals in that direction because if you're on the northern hemisphere, the center of the Earth is south, towards the south. So it spirals in one direction because Correct. Of that. If you over the equator, exactly over the equator, it shouldn't spiral in any direction. You just go straight up. If you're in the southern hemisphere, it spirals in the opposite direction. But nowadays, people are noticing that it spirals one direction one day, another direction another day.
Oh, really?
Yeah, because what is happening is the Earth's gravitational field is fluctuating.
Correct.
So it seems like, and this is probably a local phenomenon due to the stellar cores interacting gravitationally. So what it seems like is that the Earth's center, the center of the Earth, is moving around.
Ah, okay. Okay.
Because the direction of the gravitational field is being changed because of the stellar cores interacting gravitationally. Like I said before, they can actually cancel the Earth's gravitational field completely in places. Not overall, but locally in certain regions. That's how the tidal effects are occurring. That's why rocks end up on a road above a beach. All of this is caused by these stellar cores interacting gravitationally over a certain region of the Earth. So, of course, the Earth's gravitational field is fluctuating. But one thing that should happen because of this is happening is they should find it very difficult to use their anti-gravity propulsion system.
Yes.
Yeah.
By the way, you can get your own compass. I have a number of them, but to back up what you're saying, Dr. Albers, you can see now, depending if you catch it at the right time, I have seen the fluctuation literally live at many times to go as much as 6 to 5%.
Mm-hmm.
And I brought this up here because you and I talk about this every week, and I think it's great because we're getting a record of this. I marvel at the fact that we find this normal now, that the poles they're constant now in the coronal holes. It's any way you look at it. It just, I don't know. But look at this one.
It's not normal. This is one of the ways you can see the sun is dying. Basically, it's becoming one large coronal hole.
Yeah.
If you compare it with what it looked like in 2011, what it looks like now, you can tell it's dying. It's losing the corona.
Yeah, and I know a lot of people don't believe that, but you know what, folks? You cannot, I have not seen a theory, I've not seen an explanation as to why now at the polar regions of our star that it's always there. There's never no
Yeah,
more
permanent.
covering.
Yeah.
Yeah, it's permanent. Yeah.
And even close to the equator, the equatorial region is opening up with
Yeah, look at
coronal
this.
holes everywhere, small ones, bigger ones. Yeah, look at that. That opened up and the corona parted. Why did it part? Because there was obviously a stellar core interacting with the sun right there, which they obviously hid from us in some way. But that's what it indicates. A stellar core came in and just sucked some of the corona right out. That's what caused the coronal hole.
And I know
It's
this is
simple logic.
and you and I were emailing. We emailed during the week, but there are more and more articles coming out on exactly what you're talking about. The stellar cores. We don't understand our solar system. Period. We just don't.
No, we don't. And the thing is, the powers that be have not wanted us to understand. That's why we get taught everything that's wrong in school and at university. And only what is wrong is allowed to be published as research.
Yes.
Because they don't want us to know the truth, because these objects have been here for at least 150 years. They probably didn't know about them then, but they started finding out there was something wrong in about the 1960s, probably. And then everything changed. The educational programs, what was researched, even before then, it started changing at the beginning of the 20th century.
This is your latest paper that you wrote.
Yes.
On the stellar cores and the dying sun.
Yeah. And I specifically showed the evidence that the stellar cores are there. They are in the sun's corona. These are three-dimensional objects there. And anybody that tries to say that they're not there and they don't exist obviously refuses to look at the evidence. And therefore, what do I call them? They trolls.
Mm-hmm. Yeah. Yeah.
Because they will tell you a lie no matter how much evidence they see in front of them.
Correct. Absolutely.
And you can look at this. This is an object with stripes. And this object, you can see the stripes are curved. They actually follow the curvature of this object because it's spherical. How is this not evidence that these stellar cores are in the sun's corona? How can anybody look at that and say they're not there?
I'm not going to argue with you.
There are people that are still trying to say that.
I know.
Comments under my videos. So now, I answered and I say, how did you come to this conclusion? Tell me what evidence you looked at and how you could conclude that there are no extra objects in the solar system.
I love this one right here because you bring out, look at this, folks.
Yeah.
3 years ago, this is what's happening to our sun. Now, I know we're in a Mulder minimum, a grand solar minimum. I get that. But, Claudia, you take over.
Yeah, I mean, you can see that the first image is from 2018. You can see how dark the sun is getting. The second one is from 2017 from March as well, so a year ago. And you can see there's quite a difference.
Oh, look at this. I mean,
even though in 2017, I was already saying, oh my goodness, look what's happening to the sun. Look at that huge coronal hole. And already we had that permanent at the South Pole coronal hole. We already had one at the North Pole, but it was small. It wasn't. Now it's huge. We have a huge coronal hole at the North Pole, huge coronal hole at the South Pole. But this coronal hole at the South Pole seemed to have appeared in 2015 because that's the third image from 2015.
I'm so glad you did this today because that just brings to light, Claudia, what we're saying here.
Exactly. Now, 2015, the solar maximum was in 2014. So 2015 image was very close.
Yeah.
And yet we had that huge coronal hole there. Whilst 2011, don't forget that the last solar minimum was at the end of 2009. December
Correct.
2009. So that 2011 image is just over a year later. And
Look at
look at
this.
what the sun looked like. I mean, if anything, we should have a huge coronal hole at the South Pole in the 2011 image, not in the 2015 image. And that shows that the sun is being affected by these objects and drained. And these coronal holes are a result of that draining effect of the stellar cores.
This is just so striking, Claudia.
Yeah.
When you look at this, and this is a classroom setting in here, and the chat room is just full. I don't know how you argue this. I know that how they can come and try to explain it, as we just did, but folks, Claudia, this is absolutely alarming.
Yeah, it's unarguable. You can see it.
I'm just going to keep it up there because it just needs to be absolutely burned into the consciousness of everyone watching this video. There you go, folks. And even if you want to say that, well, all right, we have when we had the solar maximum here, but remember, look at here. This was coming out of the grand minimum right here, right in 2011.
Yes.
Yeah.
Look at it. They make a much difference. And you see, if we are close to a solar minimum now, we're still about a year away from solar minimum. Yeah. Then we should be able to compare 2011 and 2018 and see what the sun's supposed to look like close to a solar minimum. And then you can tell immediately the difference between the sun, and it clearly indicates the sun is weakening and weakening very fast.
Look at the corona. It's gone.
Exactly.
It's virtually gone.
Because the stellar cores are draining it. They cause this low density in the corona. That's what causes the coronal holes. They low density areas.
Look at this. Virtually, you could see in here and when it's starting. But look at here, and now look at here.
Yes.
My God. I don't know about you, but yeah, I feel real safe.
Mm-hmm.
All right. So, all right. Here's.
Okay. So this one I show because the first image there on the left is from 2017, March. And then the middle one is from November of 2016. And then the one on the right is from March 2016. You can see a huge difference in 2016 between the March image and the November image.
Yes.
So what that showed me was that something happened in between those months. And I think that a large number of stellar cores came in and started draining the sun even more than before. And then the sun weakened substantially between those months.
Striking.
They're still coming in. That's the problem. That's why the sun is not going to survive. They're still coming in. Here I start talking about what the stellar cores show in the corona, and that is these dark circular regions. And they try to use the word coronal cavity to say that there's no object there. It's all the sun. The sun's producing this. But you can see that you see that the root light connection that's characteristic of these objects as they draw matter from the sun. It's there in the first two images, which show basically the corona. That's the 211 and the 193. And it's very faint. And then in the 304, we don't see much of the corona because the corona does not emit much light in that wavelength. That light basically comes from the chromosphere. But we can see that root-like connection sticking up above the surface of the sun. And we can see, therefore, that most of that connection is coming from the chromosphere. So it's drawing matter from the chromosphere, which is deeper below the corona. And then it may not be very clear here, but I actually show that what is happening is that plasma in the corona is being diverted by the presence of a three-dimensional object.
Okay.
It's not just the corona parting for no reason. There's something there causing it to part. It's a cause and effect kind of universe. Things don't happen for no reason.
This is true.
That should be logical as well.
Logic sometimes eludes me.
Yes, but they try to come up with all kinds of ideas that make absolutely no sense to try and tell people there's no such thing as stellar cores. No, there's nothing there. There's nothing affecting the sun. So there I show again some of these objects. I wanted to clearly say that I actually think they use this coronal cavity thing, and you get lots of footage now on the internet that actually shows these three-dimensional objects disconnecting from the sun and moving.
Yeah, I have some of that footage.
They objects. Now, this is actually the 304 images, which shows the chromosphere. And the chromosphere is where we can see the most dramatically what has happened to the sun.
Wow, look at that, folks.
Yes.
Holy
That's
crap.
the 2011. And here you can see clearly that the sun has weakened independent of the solar cycle, because that third image is from, I think, 2013, and then the fourth one, so the one on the left in the second row, is from 2014. That was solar maximum year, and it's darker than the 2013.
Look at this. Now, this is scary.
It is. And you see the one above that bottom one you just pointed to, the middle one. There it looks like there's a brighter layer above a darker layer, as if the brighter layer on top is being peeled away.
Mm. And look at the odd shape of the coronal hole here.
Exactly. Yeah, it's not. This is not really a coronal hole. It's just a layer in the chromosphere that was brighter, and it's being removed because the stellar cores are just pulling this material away, pulling it away.
Very seldom I ever see straight.
It's amazing.
lines.
That image shows what's actually happening. So the chromosphere is actually shrinking.
I'm used to seeing the ropes. I'm not used to seeing the straight lines.
Yeah.
And then we come into this one.
Yeah, this one I just show how much darker even in this wavelength.
Look at this.
The sun has become. You can see it.
This. Look at that. This is stark. I have to say, Claudia, this is very stark. It just And then I just show that something either they did this on purpose to confuse the eye. Sometimes they do that, or something damaged the it's cockeyed.
SDO satellite, because this is not normal. Because the coronal hole at the South Pole became sort of went to where the North Pole was, and then got rotated another 20 degrees. So this is a 200-degree rotation. But it would be of the satellite. I don't think this was the sun itself. The satellite, but it's supposed to keep its orientation. So
they
the
say.
fact that this happened to it means something happened to it, or something went by it and affected it.
That satellite, it's,
Mm-hmm.
I don't know what they're doing on that one.
Yeah, it's very strange.
Well, that was fun. That was fun. I enjoyed that.
Yeah, good.
So I learned something.
Yes.
I love that. That's stark. That is.
Now, I wanted to mention, I'm thinking of writing something about this. The sun is dying and people are asking, okay, so what will happen on Earth? So the Earth produces its own energy from its source. So even if the sun stopped emitting all light right now, we still have heat coming from the interior of the Earth.
Yes.
And that heat will start coming out. So, but what happens is if our atmosphere doesn't have any greenhouse gases, then all that heat will just leave our atmosphere. And
are they trying to induce a greenhouse effect?
Actually, I think they are doing that with the chemtrails. The chemtrails are acting somehow like causing a greenhouse effect.
Yeah.
But the problem is they have another aim with what they are using, the chemtrails, because they're totally toxic. So it's a population control mechanism as well. They're trying to decrease the population. They're trying to kill us.
Oh, listen, I'm going to be doing a story tomorrow, folks. Tune in at noon. I did a video, Claudia. You saw it. Are they terraforming the planet for a new occupant? Folks, I have some absolutely shocking evidence to show you what they're doing to us.
Mm-hmm.
Claudia, I have the evidence that shows that our atmosphere is now permeated with plastic fibers. You can't get away from it, folks. You're eating it. In fact, we all are. We're eating the equivalency to about a half teaspoon of these plastic fibers every day.
Yeah, and it's not just plastic. It's the aluminum, all the heavy metals.
Everything. Yeah.
It's the viruses, the bacteria, the alien laboratory manufactured viruses they are producing, and they putting everything in the chemtrails. They're trying their hardest to kill as many of us as possible.
Yeah, it's
obvious. But at the same time, it does create a kind of greenhouse gas. Isn't it terrible that they're actually trying to tax countries for putting greenhouse gases in the atmosphere when, because the sun is dying, that's actually what we need?
My God. And I'm thinking about the Chinese. They're not going to be paying. They're going to say, you take your stinking tax and get out of here. I mean, here's what I think, Claudia, is that this is being held together by the most fragile tensile strength. And if it ever starts fraying, which I think it is, it's going to. Yeah. We've gone well over our hour.
Oh, we have.
Yes, we have. It's this is so here, folks, this is weird. So Trisha G, Sue G, hey, Jennifer, y'all are going to love this, right? The number has been constant at 333. Now it's dropped down, but it's been constant at 333.
Oh, that's amazing.
Yeah, go figure that. I mean, so yeah. Well, I think that this has been one of the most exciting ones so far. It
was fascinating.
Yeah, I thoroughly enjoyed this. I really have.
So did I.
Okay, so folks, go and subscribe to Claudia's YouTube channel. This is the type of brilliant minds that we need to support. And the best way we can do that is by supporting her work, supporting her videos, by subscribing. So by all means, do that.
Yeah, and I've also written 3 books now.
Oh, and are they on? Where are they at? Where can the people?
They're on Amazon. The trolls always try to leave the worst comments under them, but because they want to stop people from buying them. But
well, they're about to be hitting with the enlightened army, because we'll come in there and we'll start countering them 10-1. So it's over there in Amazon. So and on ebooks, right? Okay.
They available as normal books that that you can buy, and as a Kindle version as well.
Okay. So
I actually have it here.
Okay.
Yeah. That's it.
All right.
Yeah, it's got my latest articles on gravity, this third one. I just
Claudia, send me the link to those, and I'll
yeah, I
start
will.
linking it to the information. In fact, I want to buy some of those. So,
Oh, wonderful.
hey, Brian, how you doing, buddy? So that's going to be cool because my library won't be complete without.
Mhm.
I mean, we do a show together. If I can't buy your books, I mean, come on. That's like owning a bakery and saying, "Well, I don't eat the donuts."
Yeah, thank you.
Well, folks, it has been fun. Dr. Albers, it is always a pleasure and honor. I leave from these much more enlightened, and you are definitely providing a gift to all of us. I just want to say thank you. Buy our books, folks. Let's go there and really show her by our support. Buy the books. I'll get the link put in there later on. Folks, thank you to all the moderators. Thank you all. Brenda Fisher, Brian, Claudette, Gary, all the rest of you. Claudia, would you like to say something before we leave?
Well, I'd like to say thank you to everybody who comes to listen to this and people who leave such lovely comments under my videos. People are so kind. And I love reading the comments.
So, folks, let's just really give her a gift of our own. Give her some encouragement. Sue G the other night over on Jennifer's channel over on Crypto Truth Seekers, we can really give Claudia a lot of energy that will stay there because this woman has paid a price, and we're all the beneficiaries of her sacrifice and her dedication. So let's just tell her how much we appreciate her. I'll just say this, Claudia, this is how much we think of you.
Oh,
this much. So
that's so cute. Thank you.
And then I always tell the trolls, just
relax, calm down now. Don't stress. Take it easy.
Okay, so there you go. Just take a deep breath. It's going to be okay. Well, Claudia and I thank you. Thank you for stopping in and seeing the Physicist and the Philosopher Hour. We'll be back next Monday night. Send her your questions. If you need to, send them to me. I'll forward it to her. And we'll continue to do this. Thank you, folks. You are making this the success, and it is a delight to be here. Thank you, my friends. Be good this week. We will talk to you later. Bye-bye.